In previous lessons, we learned how to multiply a monomial by a binomial or a binomial by a trinomial. Today, we're just going to focus in on special kinds of products, notably what happens when we multiply binomials by binomials. And the purpose for this is that we want to recognize a pattern that we can apply in our work to be more efficient. So once we know the pattern and we recognize it, really what we're going to be able to do is skip the work so we can go straight to the answer. So let's get started with just a recap of what it means to square something. So if we said 3 squared, that would be 3 times 3. We could write that as 3 squared, and when simplified, that is 9. 9 is a perfect square. Same thing for 10 squared, that would be 10 times 10, which equals 10 squared. When simplified is 100. We can extend this out to variables, so a times a is a squared. And we can make this a little more complex. We could do ab times ab. And we could write that out as ab squared, or a squared b squared. We could even write it out as ab squared like that. We could even do this with binomials. So we could have something like a plus b times the quantity a plus b. And this would equal a squared plus 2ab plus b squared. And this is what we want to focus on today. Where does that come from? But we'll be able to skip straight to this once we see why this works. So let's look at how do I get a squared plus 2ab plus b squared. I'm going to use the area model or table for this. So a plus b, a plus b. This is my preferred way of multiplying polynomials. So let's start with the a times a. There's the a squared. Right, so I can put equals a squared here. Then we've got a times b. That's ab. I go down to the bottom row now, and I've got b times a. Well, that's also ab. And then I've got b times b, which is b squared. So we can see here, I end up adding 2 ab's in the middle. And when I simplify that out, that's where I get a squared plus 2 times ab plus b squared. So we're going to try this out now with some numbers involved. And we're going to see if we can get to the point where we can skip the work, we can skip the table that I just did right over here, and then go straight to something like this. So let's try this now with x plus 3 multiplied by the quantity of x plus 3. What is the answer going to be? I know that the x here in the binomial represents the a term from the example up above. And we know from our work that a times a is a squared. So I'm just going to put here that a squared equals x squared in this. The result of multiplying the a times the a, in this case, is x times x, which is x squared. My b variable up here is represented by the 3. So we know that if I square those, I end up with 9. Now we need that middle term, which is going to be the 2ab. Well, we get this result by taking 2 and multiplying it by whatever the a term is, which in this case is x, and then multiplying it whatever the b term is, which is 3. And we can simplify that out. 2 times 3 is 6, and 6 times x is 6x. So my answer would be x squared plus 6x plus 9. Now I'll do the area model or table model just to prove that this is correct, so we can see where everything came from. So let's try it out. So x times x is x squared. That works. X times 3 is 3x. We'll go to the bottom line now. 3 times x is 3x. And 3 times 3 is 9. And sure enough, look, we get x squared. The 3x plus 3x is 6x, and I'm left with the 9. So there's a proof that this does work. We'll try it again now, and we'll go straight to the answer if we can, without having to do the table, now that we see and understand that this method works. So let's try 2x plus 5, the quantity of 2x plus 5 squared. So the first term is represented by a, the last term is represented by b, and then we need that middle part of the answer, which is going to be 2ab. So a in this case is 2x, and we're going to square that. So a squared would be 4x squared. B in this case is 5. That's right here. So b squared would be 25. For the middle term of 2 times ab, we're going to take the 2, multiply it by our a, which is 2x, and multiply that by b, which is 5. And when we simplify this out, we get 2 times 2x is 4x, 4x times 5 is 20x. And if I put all of this together, I get 4x squared plus 20x plus 25. And there's the answer. So I like to do this on the side to keep track. If you're good at this and you get the hang of it, mentally you can go straight from this to that. So that's what happens when we square a binomial in which the two terms are added. Let's just briefly look at what happens when they're subtracted. So I've got a minus b, the quantity of a minus b squared. This is pretty much the same rule, except we're going to end up with a squared minus 2ab plus b squared. So the difference here is that we're subtracting the 2ab, not adding. I'll just show the table method out as a proof. So a times a is a squared. A times negative b is negative ab. Negative b times a is negative ab. And negative b times negative b is b squared. So we can see here, when I write this all out, I can combine these two terms here to get a squared minus 2ab's plus b squared. So our goal is whenever we see this, we go straight to that. And we can skip all of this work inside. That's what allows us to be more efficient. The last special case we're going to look at is called a sum and difference. So in this, we have a binomial of a plus b. And instead of squaring it, in the other quantity, we're going to subtract those two terms. And the rule for this is this will end up being a squared minus b squared. So where does that come from? Let's look at a proof. So we've got a minus b, a plus b, so with our a times a, we have a squared. A times negative b is negative ab. We go down to the next row. We've got positive b times a. Well, that's going to be ab. And then positive b times negative b, that's negative b squared. And when I write this out, I get a squared minus ab plus ab minus b squared. And here's what happens. These are exact opposites. And when I combine those like terms, they effectively cancel each other out. So I'm left with a squared minus b squared. So let's see how this could help us be more efficient. We have an example of x minus 3, the quantity of x minus 3, multiplied by the quantity of x plus 3. I'm looking at these and I notice I've got a sum and difference. The terms are all the same. That's what matters, the x and the 3's. But we're adding in one, subtracting in the other. I can go straight to x squared minus 9. Square the first term, square the last term. Let's look at another example of 2x plus 4 multiplied by the quantity 2x minus 4. Well, we can square the first term. 2x times 2x is 4x squared. And we can square the last terms. 4 times negative 4 is negative 16. And there's the answer for that one. So that helps us to be more efficient. Try these problems out. If you have any questions or want to redo a task, just email me and I'll get back to you right away.